Okay, the last section we're going to go over is metals, and it is an inorganic material. If we go back to the first unit we talked about materials, we said there's inorganic and organic. Organic being living species, and inorganic not. Comes from the earth. Metals, when they are heated, they expand. So if you think about if you wear jewelry, and this is one thing you'll realize about your body, it does the same thing. But if you wear a ring, girls, if you wear rings in the summertime, your fingers feel swollen and your rings feel tight. That's because your body expands in heat. Same with the metal. And then when it's cold outside, you can actually take that ring off a lot easier. Same with metal. It expands when it's hot, contracts when they're cooled. Most metals are not used in their pure form. We use them in alloys, which is a mixture of metals together to make them stronger or more durable, because metals are very strong and very durable. Now there is two types of metals. They're ferrous and non-ferrous. Okay, ferrous is if you guys remember the scientific abbreviation for iron, and it's Fe. That means ferrous. So ferrous is iron, and non-ferrous is without iron. So there's two types of metals, ferrous and non-ferrous metal. Most common types, steel. That's an alloy of iron and carbon. Okay, so again, pure iron we rarely use pure iron. It's usually iron and carbon. It's steel. Aluminum, very lightweight, very strong. So when you think of aluminum, most of you think of aluminum cans or aluminum foil. That's the very thin stuff. But most of your car wheels typically will have either steel or aluminum wheels. Again, if you have aluminum wheels, they're lightweight and they're very strong. We used to have a plant here in Pittsburgh. Before it closed down, that's all they did is they poured aluminum metal into molds to make wheels. And then copper, another common type of metal we use. It's a great conductor of heat and electricity, and it doesn't corrode. Okay, and we'll talk about the corrosion later, but think about copper. In Topeka, they have the copper on the top of the Topeka Tower with the Capitol. Hold on one second. Okay, I'm back. Our internet connection just dropped, so I'm turning it back on. But we were left off with the copper on top of the Topeka, the capital of Topeka, or Kansas, Topeka, and it has copper on its roof, and that copper turns green. Is that a corrosion, or is that something else? Some of you guys might already know this, but that is a protective coating that copper puts on itself to keep it from corroding, and so it is very corrosive, resistant. It doesn't corrode in the weather. Here's just some examples. Again, I talked about aluminum wheels, metals, and then earth's ceramic materials. These are the oldest materials known to man, just because we dig them out of the earth and they're easy to use. Most of you think of the clay pottery as ceramics. Yes, that's a form of what we use in art. They have high melting temps. These things can get extremely hot. If you look in your oven, down the bottom, most of those will have ceramic pieces at the bottom that hold your coils in your oven. Now again, that resists heat, so it's very, very good material. We use them in a lot of different things, but that's one example is in your stoves. They don't corrode, and they're good for some certain chemicals. And it's one of the hardest materials that we know of. Downside to being one of the hardest materials, it is very brittle. And most ceramics, if you drop, they break. They're very sharp. But again, they have its purpose for high heat and being very, very hard. Here's some types of ceramics that we use: clay, porcelain, glass, and refractory. Glass is an earth material. We get it from the earth. Same with clay and porcelain, refractory. All these are just good examples of ceramics. Here's a refractory form. Okay, composites. Composites made up of 2 or more materials. We kind of talked about it when we talked about the wood section, where we can put 2 or 3 different types of wood together and make particle board, plywood, and so on. That's a type of composite. Here's an example. Concrete is a composite of cement, aggregate, and water. Fiberglass, engineered wood panels, which we've already talked about. The picture on the right talks about or shows you engineered wood panels. We have the I-beams. Again, those are engineered. Roofing material, think about shingles. That is not just, we don't dig that out of the earth. It's actually combined of more materials in one. So we have 2 or 3 different products inside of shingles to make up the actual shingle itself. Tar, asphalt, and so on. Okay, how do we make stuff? And this is going to be the processes. You've already started doing some of this, so you should be aware of most of it. We've separated stuff, we formed, combined, we conditioned, and we finished. We've done most of these. We have not done any conditioning yet, but we have done all the others. We separate things. If you notice, we've drilled a hole. We have not used the planer, but we will use it this year. We won't be grinding, but if you think about grinding, it's taking off material from using the grinder. Cutting with the saw takes away from, and sanding. So there's a picture, just someone grinding, which in my opinion that picture looks like sanding. Milling with the machine. Again, we're taking away from the material. Here's turning with the lathe. We will not do this. Last year we had a kid come in and make a couple bats, and that's kind of what he did. Take away from the wood. So separating is our first one. Forming. Forming is changing the shape of the item. So if you think about metal, you bend it. We bent our metal boxes. Again, all we did is change the shape. We are going to do some casting in the plastics unit. Compression is all we're doing is taking something and squeezing it together. Again, we're not losing anything. We're not adding anything. We're just changing the shape of it. Forging. Think of taking hot metal and just beating it to a different shape. And some of you guys had to do this on your metal box because you bent it the wrong shape, so you had to go hammer it out. That's kind of an example of forging. I know it gets more complex than that, but that's just kind of the example. Extruding. Best example for that is toothpaste. Think of the shape of your toothpaste end has. It's got a circle, so when you push the toothpaste out, it comes out in a circle form. If you think of I-beams, metal I-beams are actually extruded. They take hot metal, and when it's liquid form, push it through a die. As it comes out, it hardens in the shape of the I-beam that they want. So that would be a good example of extrusion. Here's a form of casting. We're going to show you casting this year so you can kind of see what it is, but you're going to pour hot metal into a mold, and then when we take it out, it's actually the item itself. And down the lower left, we have just a form of bending. And so you've done some bending before with your metal boxes. Okay, now how do we join things together? Basically, how do we combine them? Well, we use certain things. Mechanical fasteners, screws, nails. We heat fasten. Welding. You guys done welding before. And then we glue the wood together. So we use screws, nails, staples, welding techniques, and certain types of gluing. So those are just ways we can join material together. Okay, conditioning. Again, we don't really work with conditioning too much. In the art department, you might. If you are making pottery, you're going to take clay and actually go through and condition the clay to become harder. And that's, we're going to use high heat. And what that does is takes the inner structure of the material and hardens it. We call that hardening and tempering. There's a different process you use for metals, for glass, for clays, and all it is you change the structure of it to make it hard so it can withstand some of the stuff that we put our material through. And the last step, the final step, is finishing. It's always the last step. It's improved the appearance and to make it last a little longer than normal. If you think about metal, if it doesn't have a coating on it, typically think of a car, if the paint's chipped away, it tends to start rusting. So it is a protective layer to protect the material, but it also makes it look good. So in our class so far, we took your ganoop and we've sanded it. We put a nice little finish on it. So that's our example of our finishing that we've done. So paints, lacquers, and you can smooth and polish metal to make it look the way you want it.